ADME studies on the drugs, absorption of the drug. So the ADME studies like ADME nothing, the absorption, distribution, metabolism, and excretion. So these are the drug properties. And well, drug is having these four properties like absorption. So when we are taking the drug, so it must be absorbed through the body tissues properly, and it reaching to the site of action. Then so distribution. So with job track, it must be distributed throughout the body by that circulate system, and it reaching to the particular site of where the disease is occurred. The metabolic The metabolic means here the some kind of drugs. Generally, they are not active before taking that, and it must be converted into the another form of that drug, like the metabolite here and excretion. So after showing the site of action, the drug must be converted into the another harmless form, and it must be excreted to the renal system here. So these are the ADME properties. So first we see that the absorption of the drug, the knowledge of the weight and here the weight and extent of the absorption is necessary for the development of new drugs. The availability of radioactive drugs enables such studies to be carried out while the discovering the new drugs. So many drugs are administered by the oral route, and most of the absorption studies are directed to gastrointestinal tract. For example, if it was shown that after giving a dose of labeled buprenorphine, there is a buprenorphine like a propranolol, okay, atenolol. So here the buprenorphine, which is antihypertensive drug, the peak concentration of the radioactivity is okay, radioactivity in plasma were reached within 2 hours in several species, including man. And only one major metabolite could be detected, which was produced by oxidation of ring methyl to carboxylic acid. So this type of result is a consequence of rapid and complete first fast metabolism in the gut and liver. The site of absorption of an orally administered drug is of interest that for its assessment in the gastrointestinal tract decline in radioactivity with time in the relevant selection of the Studies have found that absorption from the small intestine going to its relatively greater surface area. The studies of this type have been reported for the following drugs. Here we have that so the chromopro is and, select the compound. So information on the rate and the extent of absorption of radio labeled compound was obtained by comparing the studies involving in the intravenous and oral routes of administration and distribution. Metabolism studies are carried out to find out the safety of potential drugs. Before appropriate a drug for human use, the metabolites produced from the drug must be isolated and shown to be non-toxic. Isolation, separation, detection, and quantification of the metabolites is accomplished using the radio-labeled compounds and the associated techniques such as spectroscopic methods, gas, liquid chromatography, and HPLC. The primary requirement is that the radio label is in a metabolically stable position. So otherwise, the after metabolism, the radio label may get incorporated into the endogenous compounds. Quantification of drug metabolism is carried out by radio labeling. The radio-labeled metabolites are first separated by chromatography. Each metabolite is characterized and the rate of radioactive distinguishing determined by liquid signification containing methods here and the expression. So the crucial part of any metabolite metabolism investigation is the expression balance study. The purpose of this study is to account for the administered dose in terms of the proportional extracted or obtained in the body. So such studies should not have been possible without use of the radio labeled drug and the use of stable heavy isotopes in the drug analysis. So use of stable heavy isotopes labeled compound. Some common procedure for the synthesis of stable heavy isotopes labeled compound with the incorporation of the deuterium and carbon 13 in the which is presented in the scheme. You can see where this the olefin is when it is hydrogenated, deuterated with the deuterium in the palladium catalyst. So where that a saturated compound is obtained, and yeah, in the below also we are going to treating means replacing that hydrogens with deuterium by treating with aluminum oxide. Okay, then the reduction of the carbon compound with the lithium aluminum hydride means deuterated lithium aluminum deuterated Li lithium Li D4 here. So we got the alcohols. So all these are where the deuterium incorporated products obtained and the bioavailability of studies. So bioavailability refers to how quickly and how much of the particular drugs reaching the blood supply. Once all the problems associated with the absorption, distribution, metabolism, and excretion we have taken into account, the overall availability is the fraction of the ingested dose that survives to reach the blood supply. This is an important property when it comes to the designing new drugs. Next, the quality control methods in drug manufacturing and formulations. So this particular topic it deals with the study of quality control analysis of drugs. In this unit, how spectroscopy and chromatographic methods are useful in drug manufacturing and formulation is discussed. So the drug synthesis and formulation uh, the purity, quality, and those can be monitored by several available quality and quantity methods as spectroscopic methods for the qualitative and quantitative analysis of drugs. Several qualitative and quantitative methods are used for the analysis of drugs. These are used for the uh, formulation of optimized drugs. So these methods are explained below in brief form. So first we'll see the UV spectroscopy. And generally here the UV spectroscopy can be used for the detection of the chromophores, the main application. Here the several spectroscopic and here the UV spectroscopy is not widely used to obtain the quantitative information of drugs because many drugs and endogenous compounds possess the some chromophores. So, however, it is widely observational used for the qualitative analysis of known compounds. Yeah, the Bees Roberts law, one of the useful technique governing the absorption light by molecules. So this law relates the intensity of incident, initial incident and transmitted monochromatic radiation to the path length of the sample. The concentration of the absorbing compound and the molar absorptibility. The absorbance A equal to log I here the I naught by I t here. So I naught is the incident light and IT is the transmitted light here. The epsilon CL, the molar absorptivity that is epsilon is constant for the particular compound at a given wavelength and commonly expressed as the E maximum. The assay of an absorption substance may be carried out by preparing a solution in a UV transparent solvent and measuring its absorption of a suitable wavelength. The lambda, the normally selected is a lambda maximum. The concentration of the absorbing substance is then calculated for the measured absorption using two procedures like use of standard absorption and the use of calibration graph here. So in the use of standard absorption, molar absorptivity value. So this procedure is adapted for the stable substances such as like alpha methyl testosterone that has broad absorption bandwidths or particularly practically unaffected by variation of instrument parameters such as its slit width and scan speeds. So the use of standard absorption or molar absorptivity values avoids the need to prepare a standard solution of the reference compound in order to determine its molar absorptivity. So this method is of advantage in situations where the hydrogen is difficult, expensive to obtain a sample of the reference compound here. And another method is use of calibration graph. This method observes of the number of standard solutions of the reference substances are measured. The concentration of the reference substance must encompass that sample concentration and the calibration graph is constructed. The sample concentration of the solution is read from the graph as a concentration corresponding to that absorption of the solution. Use of IR spectroscopy. So generally the IR spectroscopy is useful to detect the functional groups. IR spectra highly useful in the qualitative tools to use to study the structure of the molecule as a means of identification. The use of IR spectroscopy is identifying the structural features of the molecule and as a method of identification. So two components are one and the same if their IR spectra agree in the all respects. That is a position and the relative intensity of the bands superimposable. So IR spectroscopy can be used a qualitative tool for drug processing suitable absorption bands here. Use of NMR spectroscopy. So NMR spectroscopy is the most powerful physical analytical method for qualitative and quantitative studies. Automatic integration of resonance signals in the NMR affords an easy and rapid quantitative means of determining the ratio of compounds in a maximum. So this is possible only when at least one resonance signal from each constant is free from exclusive overlap by other absorptions. So here is some examples are given. That is a mixture of acetone, isopropanol, and isopropoxyl acetate. So we can see the chemical ship values of various compounds of the protons here. So acetone with the delta, like here is the both the methyls are equivalent. So they falls in the same chemical environment. So we get that the delta value at 2.10 and integrates for 113 millimeter because 6 protons are there. And isopropyl alcohol, the delta's uh, chemical shift value is 1.12 for the 6 protons and the integrates at 192 millimeter. Same in the isopropyl acetate. Here we have two kinds of protons here. So we get the singlet at 2.1 for 3 protons and 6 protons. So here the 6 signals of stone set 2.10 coincides with the acetate methyl protons. However, the broad singlet at 1.92 is assignable to the methyl group of isopropenyl acetate. So the percentage of acetone is the peak area by total peak area here into 100. So 113 by 113 plus 192. So all total peak area here, and it is 33%. And the percentage of isopropanol is 56%. So similarly, mixture of aspirins, phenylalanine and caffeine have been assayed with the aspirin methyl acetate protons. So by this method, so we can estimate the percentage of the mixtures, yes, composition of the mixtures, like yeah, the aspirin, phenacetin, and caffeine. So the concentration of the constant in a pharmaceutical formulation may be obtained by adding a reference compound to the solution for NMR examination. Then the neglected amount of both sample and reference are dissolved in a suitable solvent, and its NMR spectrum is recorded, and the percentage composition studied from corresponding integrals. chromatographic techniques which are used in the drug analysis. Application of the GLC analysis of drugs. So, the qualitative analysis. Uh, if the condition of uh, flow rate and the temperature can be reproduced, the retention time of volume for a given compound is a given column will always be the same and can use for this identification of the compound. The quantitative analysis. The principle of quantitative analysis is that the detector produces a signal proportional to the amount of compound received by it at that instant. A peak is produced by a continuous integration of this signal while the total amount of compound passes through the detector. So this amount of compound becomes related to the peak area. Pharmaceutical applications of this GLC, gas liquid chromatography. Specification in the pharmaceutical industries, not only with drugs and chemicals, but also with the intermediates in the manufacture and formulation. So many of the intermediates are relatively simple compounds and uh, amenable to analysis, amicable in the analysis by GLC. The principle involved in the analysis of that entire sample injected into the gas liquid chromatography instrument is eluted and detected. Therefore, the total area of the peaks represents 100% measure of purity of the sample is readily determined by comparison of relative area. A bulk preparation of crystalline chemicals generally involves crystallization from a solvent. Therefore, the detection and determination of solvent residues or the solvent of crystallization forms specifications. Normally, drying procedure do not always remove solvent quantitatively from the sample. GLC's gas liquid chromatography is used to detect this particular the solvent. For example, here the methanol is streptomycin. Methanol in streptomycin is mycin sulfate. Right. So methanol in the streptomycin sulfate is removed by the GLC. Compounds capable of geometrical optical isomerism can be examined by GLC to determine their relative properties. Generally, this type of examination requires the formation of suitable derivatives. For example, the enantiomers cannot be separated directly on the GLC column except as diastereoisomers. The determination of enantiomeric purity requires the formation of diastereomeric derivatives here. GLC has been used in drug analysis and some here is the examples which are feasible for this GLC for the analysis. Here is a cephaloridin. It is antibacterial and chloroquine and clofibrate. So all these other drugs which are uh, analyzed by the GLC. Theory of HPLC in all subdrugs. Next, HPLC, it is one of the good technology. The HPLC technique is based on the same modes separation as classical column chromatography, but it differs from column chromatography in that the mobile phase is pumped through the packed column under high pressure. The advantage of HPLC is one improved resolution of the separation separated substances, faster separation times, and increased accuracy, precision, and sensitivity with the separated substances may be quantified, and it is the block diagram of uh, HPLC is given in this picture, so you can see the mobile phase column reservoir here. Then it is okay. Mobile phase is filled in the column by high pressure pump. Okay, the pressure gauge is there. How much pressure is applying, so it will be known by this pressure gauge. And here is a pumping system for the solvent, injection point here, the column, and amplifier where the detect after detection, so where the signal is amplified and it will be recorded. The signal will be recorded and finally you get the output of the chromatogram. So these are different forms of chromatography and used in PLC. They are normal and reverse phase part, partition, ion exchange and size exchange chromatography. Choice of column depends on the nature of the compounds to be separated and analyzed. Columns like PLC columns are made of high quality stainless steel of and packing material and mobile phases. Many of the packing materials used in the HPLC are based on the materials used in the classical chromatography, which others have been developed especially for the HPLC. The commonly used packing materials and their associated solvent systems in the HPLC is given. Like here is a absorption HPLC, partition here, and injection systems. Here is there are two injection systems are there. So those in which the sample is injected into the column directly, and those in which the sample is deposited before the column inlet and then swept into the column by mobile phase. So these are the methods for the injection. One is so directly injected into column, or it will be kept. It is deposited before the column inlet here. Then when we uh, means add the solvent here, so it will be shifted in the column. And the applications of HPLC in the drug analysis. Yeah, the HPLC technique is versatile and widely used for these following reasons. A wide variety of packing materials are available to allow the separation of most of the chemical substances. Various types of detectors are available that permit sensitive detection and quantification of most of the chemical substances. Micro particulate tracking materials allow excellent separation of some simpler substances, and for the faster separation and a combination of HPLC with IR-UV for the mass spectrometers allow simultaneous quantification and identification. So due to these all these reasons, we are using the HPLC. Next, use of TLC. Generally, here the TLC exclusively used in the anal soft drug because of the simplicity and low cost here. It offers a faster and more efficient separation of the substances. In TLC, substances separated and the differentiated migration that occurs when a solvent flows allow this thin layer of the fine powder separated on the glass or the plastic plate here. So generally in the TLC plates, we prepare the TLC plates with the silica gel here. And here is the preparation of the TLC plates and the ingredient and the application of this. So we'll see the coating substances, solvent system, the mechanism of separations. So we'll see silica gel or the alumina, right? The materials preparations, TLC preparation materials, silica gel or the alumina. In that case, if the preparation materials are silica gel or the alumina, so we use the solvents, chloroform, and methanol in 9:1. Means for preparation of the silica slurry, 9:1 ratio. And the mechanism of suppression is absorption uh, technique, absorption procedure. Okay, adsorption only, not absorption, because adsorption is a surface phenomena, absorption is a internal phenomena here. So where the compound is adsorbs on the surface of the that particular silica. Diethylamino cellulose, 0.1% aqueous sodium chloride, and ion exchange method here. And cellulose are the silica, where we are using the barium hydroxide and aluminum hydroxide and water in 4:1:5 ratio. The mechanism of separation, the partition here. Next, paraffins are the silicon oil coated on silica. So here the water in the is 2%, reverse phase partition. And Cephodics G50 polyglycose here. Aqueous buffer is the solvent system in this particular uh, preparation. And molecular exclusion method, separation method is applied